I was first interested in computer by the end of the 80s when I come to the university, and there was the occasion of developing from the beginning the new computing services of the department. It was the first year of the internet connection in Italy and so on, so we have the possibility of playing and enjoying a lot with the technology of the time. So we have developed system mainframes, first PCs, first teaching room, and so on, and first internet services in the early 90s. This is what we had done at the beginning, and now we have evolved to these new technical systems. I work for the University of Pisa. I'm in charge of the computing services of the Department of Physics. That is probably the most computing demanding part of the university. And we have started doing some testing using clusters of standard machines in 1997, doing the first test for some application and so on. And we have we are continuing testing all the new technology that are tied to high performance, technical computing, visualization, and so on. Our work of the last 2-3 years is in designing an operation of the benchmarking centers we have set up at the university for our internal use and for external customers. So we have designed from the beginning all the data centers, from the air conditioning to power supply to rack design, and we have deployed a lot of systems, a lot of clusters, little clusters and big clusters. We have a lot of technologies, either on the hardware side or software side. So we are interested in all the new technology that is coming out in order to implement this cluster technology, high-performance computing technologies, and so on. The problem of the exploding data size is probably one of the most challenging factors for the near future, because as we are able to deal with complicated computing clusters and so on, InfiniBand networks or new generation networks, dealing with a lot of data size at the moment is still an open problem, and is one of the things we have to work hard for the future. For example, in our lab, the high energy physics data size from the newly started physics experiment at CERN, they are promising us a huge quantity of data, and we have to understand very well how to deal with. So technology like parallel file systems or similar are what we have to investigate it very well. Sure, power consumption is a key factor, but what, according to me, is we have to achieve a better understanding is how to make software that is able to use our architecture the best way. Because typically we have now cluster architecture that are able to save power consumption, to use, you have a lot of multi-core machines, you have a lot of power, computing power for less power-hungry machines. But probably we are not at the stage where the software is able to use this architecture the best way. So we have to invest more in software, in how software can use this architecture. It's exciting. But with this last two years, with all these new technologies coming out, coming down to the real people, because now in our labs you have technology that until 10 years ago you can imagine to have is very exciting. Also for new students, also for us.